that. And Dr. Pradeep Desai, it's over to you now.
Thank you. So, a very good morning to all of you. I'm very happy to be here in front of, to kind of talk about the industrial internet. Before that, really, I'm thankful to Shivakumar, Amarnath, Anbu to kind of invite me here to speak on behalf of ICT ACT and to all learned people in front of me. This whole stuff about internet, industrial internet, internet of everything, internet of things, all kind of words, actually, you know, it's very simple. It's basically what's happening is people are trying to build a network. And it seems that the power lies in the network. So as soon as you start to have two people talking, you have a certain level of power. If three people talk, it kind of becomes even more powerful. So just extend that. It kind of just starts to increase the power of anything that you're doing. So I don't want to talk about internet or internet of things, but I want to quickly talk about industrial internet. So what is industrial internet? For a company like GE, which is into the industrial space, we coined this word because the data that we work on is machine data. They're sensor data, all data that comes out of either our aircraft engines or locomotives or healthcare equipments, and therefore we use the word or we called it the industrial internet. Now, what is really industrial internet for us? In GE, industrial internet means three things. First of all, it's about intelligent machines, right? Second is advanced analytics, and third is people at work. So I'll explain to you what it means. When you talk about machines today, a lot of machines are, pretty much static. They need to be, there's a knob or you need to control it. You need to do a lot of stuff on it. We're trying to move to an era where we're trying to make machines intelligent. It's almost like a human being, right? For example, I'm kind of running cold, but I know what to do to myself to get out of cold. So we want to make machines like that. So we want to make machines intelligent, right? So if a machine is running at a speed which it is not supposed to run, it should actually understand the ecosystem or environment and start to control itself. Or if an aircraft engine is flying across Middle East, it's very different from flying in in another place in North America where the climatic conditions and the weather is very different. The aircraft actually understands how to fly. So that's a little bit extreme, but intelligent machine is all about trying to make machines intelligent. How do we make it intelligent? So to make machines intelligent, there should be a mechanism for the machine to kind of use some indicators. Only when you get indicators, you can do something. When somebody falls sick, you can feel his temperature. You can feel certain symptoms. Now, those are called indicators. Now, how do you take those indicators and kind of have a feedback mechanism to kind of set right the system is basically what we're talking about intelligent machines. Now, in its sense, there is data coming out of this whole engines that we build. Now, just having data means nothing. So data has absolutely no meaning. In fact, there's so much data in the world today that people don't know what to do. So at one end, people want and aspire to have a lot of data. But actually, we are in a dilemma to understand, why do we need this much data? And therefore, it is very important to look at something called analytics. In fact, we call it advanced analytics. Because at a certain moment in time, data is going to overwhelm you. Just because you have data, just because you have access to the internet, just because you can go to Google and search something, really means not so much. What really it means is, are you getting the right information in the context in which you're working, in the context in which you are, right? And that kind of intelligence through analytics is extremely important. Just to give you an idea, when we actually sell certain machines in certain locations, right, we have done a lot of design changes. And that intelligence actually came from not just looking at a pattern data, but ability to do some kind of advanced analytics. We have actually gone and understood why certain things work very well in certain places, why certain things doesn't work in certain places. So from a GE's perspective, it's extremely important because we as a global company actually sell some of the mission critical systems. When you talk about an aircraft engine, it's not like social media. Because an aircraft engine, when it's flying, by chance something happens, you know what will happen, right? Therefore, we have mostly twin engine aircrafts today. Even if one engine fails, there's another engine to take off. But the point is, in this world of highly networked and heavily remote control, and all of that you're giving control to the machine, it becomes extremely mission critical to get this whole equation right. If you have a robo actually in the future going to do a kind of tumor removal from your brain, it better be accurate. We don't want it to go and remove something else. So we are talking a very different kind of business in which we are. When you build a nuclear reactor for somebody, right, if the nuclear reactor for some reason fails, you know what will happen. I mean, you have seen examples in Japan. Now, this is completely a different ball game when you talk about the social media aspects of data. So therefore, the industrial data, or the industrial internet, comes with its own challenges and complexity. Secondly, the data is much, much bigger than social media. It's almost like 1,000 times more data that churns out, is being churned out. And then therefore, we need to understand also how people work, right? To just give you a simple example, it may look very funny to all of you, is that if you have a driver who drives your car, and if you drive your car, there's a huge difference on what happens to the car over a period of a couple of years. Now you wonder, the car is a car, so why should it matter? Now I'm just pulling this analogy to aircraft engines. Just understanding how an aircraft takes off and lands, which is the most important aspect of an aircraft, is that the maximum stress an aircraft gets is when it takes off and lands. That's the only time it goes to tremendous stress. There's so many things happening on the engine at that time. Now, a pilot who is very kind of, very well tuned, very experienced, knows how to, you will have flew many times and seen that. And if you sit, and when I sit in an aircraft, I know already how, especially those which doesn't have auto-controlled, auto-piloted takeoff and landing, you can easily figure out whether this pilot is good or bad. So it has a tremendous impact on the aircraft engine, right? Now, why is this important? Now, why is this industrial internet important for GE? The industrial internet is very important from GE, is leaving aside all the technology side, I'll really come to the technology side very, very quickly. Leaving aside all the technology aspect to it, the industrial internet, or maintaining and writing contractual agreements on the equipments that we sell from GE, is billion-dollar business. You may wonder if I tell you that today GE sits on a $140 billion CSA contract. That means GE has signed off that will support your machines, either it's healthcare or turbines or locomotives, or energy nuclear reactors. It's $140 billion. Now, is it good? You can feel very happy about it. But the commitment we have is that if it fails, we're supposed to pay back. If an aircraft engine does not take, and we said we will maintain it, it will fly. And if it does not fly, GE has to pay back to the airline company. If the engine just fails, the airline will just say, you said it will work for the next 10 years, it just failed. You better replace it. Now, that's why for GE, the industrial internet is extremely important beyond selling equipments. Beyond selling hardware, the software aspect and the analytics aspect is extremely important. Now, so the combination of how people work and making machines intelligent and actually applying analytics on top of it is what we call as the industrial internet. Now, why do we do it? Like I said, it's going to make it much better, faster, and it's going to actually be able to do things in real time. And that's what, it's also about not G as a company, it's also about many others who want to get into this field. So it's a very, very competitive world, and really the differentiator that we can have is to provide this kind of value adds. So this is industrial internet. Now, what comprises of an industrial internet, right? So to make an industrial internet, what do we need? So there are some key things, and I want you to watch this particular slide most focusedly, because you as professors, educationists, I think this is the future, in the sense that this is what's going to be talked about, and you already hear. There's a lot of buzzwords, there are a lot of things, right? But pretty much is the same thing, right? Big data. So today data is pervasive. You really don't know where your data is. Do you know where your Gmail is getting stored? Do you know where information is getting stored? The mails that you send, do you know where it is, on which server? You have absolutely no control. Do you know what Facebook does to you with your information? So, and then this data is on different forms, right? It's not just a set of tables, but it's all kind of data. It can be pictures, it can be videos, it can be X-rays, it can be, you name it, everything. So your ability to actually manage this kind of data, volume and variety, is a big deal. It's not easy. So a lot of research is happening on this aspect of ability to take big data. The single most importance of big data, if you can get it right, is it actually does a disruption. The disruption it does is, from an analytics standpoint, is really that if you are from stats background, basically analytics is two things. One is statistics, and two is machine learning. I mean, it's from math, but basically it's two things. If you understand stats, what do we do in statistics? In statistics, we do a simple thing. We actually take a lot of data, and because you can't handle the data, you sample it. The minute you sample it, things go wrong. Because many times when you sample it, the sample is not a representation of the whole data set. And that's why big data is making a disruption. The ability to look at the data in the holistic terms is extremely important than sampling it. So people wonder, why does things don't work? It's because the sample that you take is not a complete representative sample. Like I gave you an example. When you say an aircraft is flying, means really nothing. And if you take a sample where you took the aircraft was flying in a nice condition, is very different from a sample which you are taken from an aircraft which is in a very harsh condition, like the deserts. So that's why big data is becoming extremely important. A lot of people are talking about the cloud, so I'm not going to talk a lot about it. Fundamentally, just imagine it's a simple thing. There is somebody somewhere is giving you this infrastructure. What is that? Computing and storage. And people are saying, why don't you come and use it? Why are you building your own house? Here is a nice building. Why don't you just walk in and start using it? So that's a simple analogy. And if you want to, on each one of these topics, I can talk for hours, but given my time, I just want to go fast. So cloud, I'm not going to talk too much. This is the third one, is access, right? People today are not bound by distance or at a certain space or location. People want information everywhere. So our ability to actually have access wherever I am is extremely important. So that is what access is, right? Security is extremely important, like especially for us. It is not like even if you lose some money in the bank, it's okay. If somebody hacks into your credit card and takes money, it's fine. But for G, it's extremely important. We have from the US government, and also not just for US, but for countries like ours, that people want to hack into systems like nuclear reactors. Can you know what will happen? This is not like having a war. This is like sitting somewhere and getting into your nuclear reactor and getting it wrong. And that's called war. That is a very different kind of war. So this becomes extremely important. User experience, I think a lot of you must be knowing, it's the ability to make things easier, faster, intuitive, right? Can I make what I give as simple as possible for people to use? Brilliant machine, I talked about it. How do I make machines intelligent? Asset management is very particular for GE. Is about how do we model our asset. We actually seldom really do something physically today. We have a complete simulation of a lot of stuff. We don't touch materials before we do a complete simulation. And there is this whole topic about output of it that drives into advanced manufacturing. We call it the 3D printing, is our ability to create and model assets, right? So we can actually do a whole lot of what is called as asset management by just doing simulation. So these are actually some of the key pieces, and I think you should take a note of this, because this is what is the important topics or the trends in the future. For GE, like I said, right, the company is 70% industrial, and therefore, like I said, it's called the industrial internet. So we are in power and water, energy, oil and gas, healthcare, aviation, transportation. GE Capital, which is our financial wing, is about 30% of the company, and then we have a very small business of home and business solutions, right? Now, like I said, why is it very important for companies like GE, right? Definitely for GE. So here is, I have more examples of this side, but I just picked up 3 things. Just a 1%, we call it the power of 1. If we just improve the efficiency of freight utilization by 1%, freight is like, you send, a lot of goods on the railway, on the train. If I can do a 1% efficiency, and if I kind of accumulate it across 15 years, it will give us $27 billion saved. So, and you wonder it's just 1%. It's not like you're dramatically, it's not like you're coming out with a new product. It's not like you're coming up with some of the out of the world stuff. You're just trying to do efficiency improvement. Similarly, in the healthcare, if I can, come up and understand that my CT scan is going to fail, like in 6 months' time, can I do a predictive maintenance? Because if a CT scan fails, the hospital really suffers. So if I can just do a 1% on that, it's a $63 billion. So these numbers actually, and again, predictive diagnostics for power, right? If the power is going to fail, can I predict when the power is going to fail? That's about 66 billion. So these numbers are very, very interesting because, and it's very doable. It's not like rocket science. With what we are doing, we are very confident we'll do this. So this is no rocket science, but it's just the thought that when you start looking at this number, this technology becomes important. So the takeaway is, for all of you, I think from a standpoint of, what is the takeaway? I would say for you folks, this is important. And for industry, basically, the business is important. No company in the world exists if it doesn't mean money. So, with that, I want to just run one video. And the video actually will give you a good insight of what is this industrial internet about.
There's a whole new internet at work. Machines communicating with machines, sharing a wealth of data seamlessly, tirelessly, behind the scenes. Forget real time. This is between time. Machines moving industry forward at lightning speeds. Welcome to the industrial internet. Out at sea, a large cargo ship traverses the giant waves, carrying parts destined for a far-off wind farm. Tiny sensors throughout the engine ensure everything is working properly. They report back on propeller performance and power output. Other sensors above deck monitor the ship's precious cargo and confirm its condition and safety. The ship's tracking data determines the destination and arrival time. Everything checks out. The cargo is now traveling securely aboard a hybrid evolution powered freight train. Inside the cabin, the engineer calls up a status report on the entire train. Real-time slows, Between time, a vast universe of data is collected and interpreted. In the blink of an eye, sensors calculate engine temperature, fuel efficiency, speed, weight, and vibration patterns. At the same time, sensors in the track relay the train's location to the network, where information from all other trains comes in. This gives the network the ability to coordinate movement and optimize efficiencies throughout the entire system. And our train remains on schedule. Meanwhile, at a nearby wind farm, a new turbine powers up for the very first time. Within seconds, tens of thousands of data points are analyzed, and the farm controller delivers operating instructions to the turbine, bringing it up to speed with the rest of the farm. Leveraging thousands of hours of stored data, the farm automatically calculates how to increase and decrease individual turbine output. The turbine can tailor the pitch of its blades to capture just the right amount of wind. As the farm responds to the demands of the power grid, it delivers energy as instructed. Next, the grid carries precise amounts of energy to a network of local charging stations. Drivers can charge up and head home. This is the Industrial Internet. Brilliant machines, providing the insights to make better decisions.
So thank you very much.